It's kind of have to go fast. All right, so today we're going to talk about DNS, the domain name system. This is sort of an application. It's kind of an application in the internet. Right? The internet usually you think about packets being sent to an IP address. Right? We haven't really seen what this looks like yet, but it's pretty much just a little header that says, this is the address I wanted to go to, and it's a 4-number address if you're IPv4. So there are no names in there. You'd have to know the address it should go to, and the packet gets delivered there, or maybe it doesn't. That's what the internet provides. So to make it a little bit more user-friendly, there's all sorts of services, and one of them is this domain name system, which is, without it, it probably would be very difficult to use the internet. You probably have noticed that, okay, here we go, close this. Way too many windows with way too much secrets, admissions information and such. Let me see what we can do. That's not admissions. Okay. All right. Right. So we say this, right? www.cs.uic.edu. It feels like that's just how we type web addresses, right? But you cannot send a packet to a name like this. That doesn't work. So what we've been doing so far is we say, oh, host, like that, and now through some magic, we look up the corresponding address for this name, and after that, now we want to connect with a socket, at least with a normal low-level Unix socket API. We just specify this address. We don't talk about the name anymore. The name's gone. If you're doing a web, if you're a web client, you actually have to remember the name a little bit longer. You have to remind the server which web address it was you wanted to access, because many servers actually serve lots of different domain names. So then you have to remember it. But for a mail server, you just connect directly to this IP address, and then you say, deliver to this address. I guess you have to remember which email address you want to send to instead. But it's sort of disconnected. At this point, we just are able to connect directly to that piece of infrastructure. But if we go, okay, that's I guess a little bit simplified. Let's use a larger query. All right, so here, dig is just a little bit more verbose. Host is fine for all intents and purposes. Dig tells us a little bit more about what the answer really was. So I asked this question. I requested an A record, saying I want the address. There's a few different types of records. There's also NS records that say, oh, which name server is responsible for this address? Like, who is the authoritative source? Who knows what the address really is? And that's this one, right? Or actually, it's one of these 4. And then one more thing. Here we're saying, oh, and by the way, these name servers are just little programs that take one of these questions and send back an answer in a kind of a clever binary format. Oh, and by the way, the name servers have these addresses. So now, in principle, we could go and ask them directly, but actually, how do we get this in the first place? And this is what the homework is all about. So in this homework, we are talking directly to the domain name system. Usually, you have sort of a local agent, much like with email, and you rely on this local name server, or DNS server you may have configured in some access point or something at some point. So the DNS server you usually configure, that's some local agent, someone who's supposed to help you out, right? And they do all the work for you. In this homework, we don't use that. we talk directly to the global DNS system, to a bunch of different servers to find the answer to our question. Okay, so how does this all fit together? Maybe I should draw a little ugly picture. I should save this somewhere. All right, so here we just relied on the domain name system as one box, but today we're going to split it up into a few more pieces. Okay, so here's our client. And in this case, we're a DNS client. We're not interested in whatever server we're looking up here. We just want the number back, and then we're done. Yeah, question?
In the console, the A column, there were, in the additional section, there was 1A and 4As besides.
Yeah, very good. So this is an IPv4 address, it's an IPv6 address.
Well, what do the A's mean?
Oh, it's just the type of record. So this is, in the DNS system, this is an A record for address.
So IPv6 is a quad A record?
Yeah, it is 4 times longer, so that makes sense, I guess. Yeah, so there's a NS records. Another one that's really important is a PTR record that kind of goes reverse. We'll see that in a little bit. Okay, so we have our DNS client. And now we're looking up some domain name, and usually it'll be our local resolver or local DNS server that answers the question. Right. This one, in turn, it doesn't actually, it keeps a little cache. In fact, our local machine, it already knows what is the answer for google.com, right? That's sitting in a little cache, so it doesn't have to go and ask every time. Same thing with the local resolver. It probably has a larger cache. So it remembers for a longer time, like what the answers for some of these questions are. The answers come with a little timeout. So they'll say, oh, this one is good for a day. After a day, throw this copy out so that you go and get a new fresh version. There's no way to invalidate something. If you change it, there's no way to just go and change it in all of the various caches all over the world. You have to say ahead of time that this one could change within 24 hours, a month, something like that. And then it takes a month before everyone knows the new version, if you leave it at a month. So there's obviously trade-offs there, right? I guess we'll get to that in a little bit. So the local resolver, it needs to figure out, let's see, let's go with google.com again. So how do we figure out the address of www? This is maybe I should explain this, although I think most of you are familiar with it. Usually you think of this as sort of the domain. Like this is a group of machines, and then usually you think of this as the host, a particular machine that we want to talk to. In the case of www.google.com, it's not a one machine, and the answer that we got is a fairy tale. If we ask again, maybe we get different answers. Let's see. No, we always get the same answers. In principle, we could have gotten other answers. I'm sure there's 10,000 machines who answer to this host name. And probably this thing doesn't even go to a web server. It goes to a load balancer, a little in-network device that then has thousands of machines behind it and so on. It's a bit of a fairy tale, but if you go to UIC.edu, I know for sure that this here is one little weak machine sitting in RRB on the other side of Halsted Street. Okay, so www is probably, usually it refers to the machine we want to talk to. So that means the rest of it is who we should be asking, right? So it's not that the entire world has one big table somewhere where you store the IP address of this whole thing. We divide it up into lots of little autonomous pieces, and everyone is in control of their piece. So here at UIC, computer science department is in control of everything that ends with cs.uic.edu. So the ACCC, they can't make these changes. And we, on the other hand, can change what's at uic.edu. We've asked them to please give us authority over cs.uic.edu. That's up to them to say, but they've decided that's fine. And then it's up to us to say, oh, there's a server that is part of our domain. In fact, John Fike in the back here is in charge of the DNS for this. I think you are by now. Yeah. Okay. So how does that all work? So now the local resolver, it gets this mysterious query. And then what? Well, it looks like it should be asking whoever's in charge of .com, right? To see who is Google. And then on from there. But who do we ask about who's in charge of .com? There's lots of these top-level domain names, right? TLD, top-level domain name. I'll put that in there. It's just good to know some acronyms. Okay, there's a bunch of even higher level, more important servers out there. They're called the root servers. DNS root servers. So they are in charge of the empty space over here, right? That you can ask about any top-level domain name. All right, so we start by asking the root servers, one of the root servers, who's in charge of .com? How do we know who's our root server? And we want to talk to our root server to get the answer, just like we don't know who's in charge of .com. This is what's it called? One of those Russian doll things, maybe. Any ideas?
Maybe just everybody knows them.
Yeah.
All computers know.
Okay. Here they are. So, here are the root servers. Bunch of different organizations are in charge of them, at least according to the sort of legend. Some of the root servers are hiding behind fake storefronts in parts of the world, and many of these don't actually go, many of these addresses, through special magic in the BGP routing tables, they don't actually go to just one place. They're multicast addresses, which is not something that most people use, but this is such an important service that one of these addresses might lead to hundreds of different machines in different parts of the world. The general idea is you pick one at random, and then you hope to get an answer. And if you don't get an answer, you ask a different one. And they are all supposed to keep the same small bit of information. All they keep track of is for each of .com, .edu, .net, .org, .gov, .se, .de, .dk, and so on. You know, all of these country names, and now there's some more. What is it? It's like .tv and .business and I don't know, .me.
Those are just like stored in your OS or something?
Those are not stored. These are stored in your OS. Yeah, and in fact, for our homework, you get a little list with these IP addresses. That's sort of where we all start from. Right, and all they are in charge of, all these machines, and there's many more than these, all they are in charge of is to remember what IP addresses where are the name servers for the top level domain names or domains. Okay, so that means that next up we will ask the .com TLD server. So the local resolver at first asked, say now that we didn't have anything in the cache, right? We didn't already know the answer for who's in charge of .com, which is kind of unlikely. So we went and asked the root server, we got a response saying, oh yeah, that's this guy over here. So we'll send another request to here, usually you would get many responses back. Right? It'll say, oh, there's a whole list of these various machines that you could ask. We go and ask the .com, TLD, and about google.com. Right? And they'll say, actually, we could send the whole request. We send the whole www.google.com to here, and they'll say, oh, I don't know. But I know that .com is served by, and then the name server. Right? So you have an NS record that comes back. Okay, so we go to .com, and then this, I guess, gets pretty obvious. Domain name server, so DNS, right? Or name server. So we ask that one, and then finally we get a response back from this one, because that's the one that's in charge. We get an authoritative answer saying www.google.com is at this IP address, and then we're done. That application is finished. It's an application because the DNS client is just sending IP packets, and the servers are just sending IP packets. In principle, we don't need any of the fancy BGP interference that's happening with the root servers here. If it wasn't such an important service, you could just have these 12 machines. Is it 12? It used to be 12. Looks like a little more than 12.
I think 13.
13? Yeah. Yeah, 13. That's right. It used to be 13. See that in a bit. Right, so all we do is send IP packets back and forth, and eventually we get an answer. So the internet doesn't get involved in any particular way. Right? It doesn't know about this service. It doesn't at least need to know about this service. Okay, let's try this with a little tool that I built. No. And you'll, not solutions, let's see. Okay, so you will have access to this as a template for making the homework 3, it should be homework 2. What am I doing? Oh, in fact, yeah, it was homework 3 at previous semester, but this is fine. We'll just call it homework 3 for now. Okay, so the tool works like this. You tell it, I want to use a certain name server. Let's pick one of the root servers. And now we want to look up that. All right, so now we've got an answer. It's not exactly the answer we wanted. Right? I asked the root server, one of the root servers, about this cs.uic.edu. And all I got back is saying, okay, in fact, let's get a little more verbose. We'll use a D here. So it says, the name edu can be resolved by, so this is just me printing stuff up. It comes back in sort of a compact packet format, and we can look at that in more detail later. But you don't have to do that because it's in the template already. It's kind of provided. Okay, so this name can be resolved by one of these servers. One of these servers, here are all their IP addresses. That's really nice of them. They don't have to do that, but in this case, maybe it was quite useful. So now we can just ask one of those servers about the whole query again. So now we're asking an edu server, right? The name edu can be resolved by these servers. So let's see. So now we're getting to the UIC.edu can be resolved by one of the UIC DNS servers. And here are their IP addresses, really nice. In one of the problems that we'll do for the homework, we don't actually get that answer. So then you have to go and find the IP address of the name server too. Okay, so let's ask that one. Oh, look at that. We have to check one more. In fact, I think we're going to move away from having our own name servers at some point. We'll be using the UIC name servers, but here we are. Let's ask the CS name server, fred.eecs.uic.edu, EECS from way back before I started, when it used to be one department, electrical engineering and CS together. And there it is. So we got the answer, and that's our web server. Let's see if it works. I think we may have to provide the IP address in order to get a sensible answer. Sorry, the web address to get a domain name to get a sensible answer, but let's see what it says. Ah, look, it actually figured it out. Good.
You know why it's called Freddy Darson?
I have no idea why they're called Freddy Darson. Yeah. Okay. So that's the general process. Of course, what you usually do, like, is this. You ask your local resolver, how do we know who your local resolver is? Configuration. A configuration file on a Unix machine, it'll be hiding in here. There's your name server. A local resolver is this helpful server that will do all the work for us, right? So now we can use this client that doesn't do all the work. You know, this client only makes one request and gets an answer immediately. It doesn't kind of follow all the clues to find the final answer. But if we ask this local name server, we'll get a complete answer directly. What? Really? See? Okay. Sorry about that. I guess we don't. I don't know why. You may have seen this too. I think this is Google. They provide like a resolver for everyone. Oh, they're so nice. Oh. I guess not. I'm confused. I will have to resolve this some other time. Yeah?
When you use the Google DNS resolver, what information is being provided to them?
Yeah, so you, of course, you have to provide your question, right? What it is you're looking for.
What do they get?
That's what you get. They get. Like you send the domain, whatever you want to resolve to them, and they see where it came from, the IP address. And so that's already quite helpful if you want to be a spy agency. So they will know every website that you visit, let's say. But it's somewhat hidden by the fact that you're using an IP address. If you're sharing an access point, they don't usually know which of your roommates is accessing the website. And if you're behind a larger firewall, like in many companies, it'll be just, oh, one of the employees in this company was interested in that website. Right? So it's not all that fine-grained. They have much better ways of spying. So yeah, I don't know what this means. It's been a while since I wrote this program. But in any case, let's take a quick look at the template to see what it does. So actually, this will be more useful. So a DNS request, it's called a UDP datagram. So UDP is basically sending these raw packets, but you also get to specify which port you want it to arrive at. Port in this case is 53, I think, for DNS. So we tell the Unix socket, oh, send this packet to the destination, address this, port this. IP doesn't know about ports, but UDP does. We'll know about that later. So within that packet now, the DNS server will receive some bytes. And it's not a bunch of strings. It's a relatively tightly packed struct with the question that we want. It looks like this. Actually, no, it'll be easier to just show you here. It starts with a header. So some ID like, oh, this is request number 17 from this machine, so that you know when you get an answer which request it was. and then a bunch of like how many questions were there, and if it's an answer, it'll be a number of answers, and so on. It's just to know like what's coming. And then there's a bunch of these resource records. So here we would then we would put our question in here. Like, so it'll be the header, and then we say, oh, there's one question in here, and then comes a resource record that says, oh yeah, this is a kind of question, like it's a request. I'm interested in an A record. I want the answer, right? And then finally, the string I'm looking for is this long, and then comes a funny-looking encoded string with the www.cs.uic.edu, but it doesn't have dots. It has some numbers in there instead to say how long is the next piece, so you don't have to scan for dots to go a little faster. So here's an example of what that format looks like. But basically, when you want to send a DNS request, you put together one of these binary blobs with the information, you send it off, and you get back another binary blob, which we decode in this little piece over here. So this is this DNS.h, which provides these handy little functions. And then homework 3.c is your template, which puts together a query given a string we're interested in. Oh, I guess this is the string that we're interested in, the host name we're interested in. So it just sends out parses some command line arguments, sends out the request to the appropriate server, and then nicely prints out the result. So here's the stuff that's printing out resolves to IP address. We got a rect type A in the answer. So you can study this on your own time to kind of get a feel for what it is to send these structs over the internet. It's not so different from talking to an SMTP server. It's just a little different format. It's certainly much easier to do in C than to do in, say, Python, where it's hard to deal with fixed size structs and easy to deal with strings. Okay, so the job for the homework, and I will update this slightly with, in particular, I have to find a place to put my homework template. I think that'll go on just GitHub Classroom. The job is to change this template code so that it actually finds the final answer. So now, if we're asking a root server for www.cs.uic.edu, we just get, oh yeah, you can ask edu about this address, right? But we want to find the final answer. And it's not always that easy. And so I wanted to show you, let's see. Okay, I don't know if this is the one I was using before, but let's, no, it's got a little, I had it somewhere else. That's the one. Okay. So we still need to say where we're gonna start. No, we don't actually. I think I fixed that. All right, let's try this. This is just a really nice problem, and I'm so glad that for, I don't know, probably 10 years now, I think, this domain name has resolved the same way. Look at that. So we're starting out saying, oh yeah, we're using this name server. The program automatically picks a name server from the root list, and then now we start looking up this, right? Using the root server, and then we get, oh yeah, TW. Go and look, ask one of these. So we ask one of those, and then it continues. Yeah, awesome. All right. So that's how you resolve that domain name. And it doesn't take a lot of work. This homework is probably like 10 lines of code, something like that. But it's going to be pretty hairy to figure out the homework template and figure out where you're going to put the changes. Right? There's just a few little changes to make it do the whole thing, but it's they're kind of tricky to get it quite right. So naturally, you are not allowed to use get host by name or get adder info here, right? And there's no popen or anything like that. We're talking directly to the name servers. You already have the template to do that. There's one nice hint here. You probably want to use recursion. If you don't use recursion, I cannot promise the 10 lines. Right. You're also expected to deal with root servers that are non-responsive. So the list of root servers that you have is correct, I think, what you're given. But you can put some bad ones in there that don't respond. And no matter where it is in the list, right? In particular, if the first one, because you're probably going to use the first one, right, from the list. But if you hit one of those, you should handle that, the fact that you didn't get a response, and go try again. And the same is true for all the other servers along the way. It's not that unusual. You send a request to a name server. The name server may be down, or maybe the packet you sent, because this is with UDP, it's not reliable. The packet maybe just got lost along the way. So you sent your question, you never get an answer, then you have to recover from that, send the question again, maybe to someone else, until you get the answer that you want. Okay, so the turn-in, I think this is a little outdated. I'll update this. And we have some examples of like easy and complicated things to resolve. Yes, and since we have a few more minutes, actually, it's 50 minutes, isn't it? Yeah, good. There's one more thing. You know, we're used to just asking about these names and getting an IP address, but what if we have an IP address and we want a name? That can also be useful sometimes. It is really useful for this mail thing that we were trying, right? If you're checking if this is a legit mail server, it'd be pretty nice to just look up the IP address of the sender to see if it at least resolves to, you know, the claimed sender's email domain name. So for us, I'm sending something from UIC. If you resolve my host name, it probably should be a UIC name. So let's try this. This is one of my server machines. Unfortunately, my laptop gets one of these lame IP addresses that look like this. We'll find out later, but anything that starts with 10, it's not a real IP address. It just means something locally, but it doesn't mean anything to the internet. You cannot route to this address from somewhere else. And the reason is that there's copies of that address all over the world. Thousands of machines have the same address. Same thing with something starting with 127. But for anything that needs to be reachable from the internet, like a server, like my thing that I was just trying here, nodes, it needs to have a real IP address. This is reachable from the whole world. So I can also say that, and now it says, through some relatively cryptic answer here, right? But it does say that's the domain name. Well, it's not entirely obvious that it would work like that, right? So let's try another one. Google.com looks like this. That doesn't look anything like it. What's going on? There isn't a one-to-one mapping between domain names and IP addresses. So any domain name can map to any IP address. We know how it all fits together now, right? I own some domain, jacob.com, right? And I can put whatever I want in there. So if I have jacob.jacob.com point at one of Google's servers, Google can do nothing about it. This is just a lookup table, and I put whatever I want in my lookup table, in my part of the lookup table. But what about the other way? So someone owns this IP address, and it's not me. So I should not be able to change change it so that it looks like let's see. I should not be able to change it so that Google's IP addresses resolve to my domain name, right? They should be in control of naming their IP addresses. So the way that works is you just come up with a reverse weird-looking domain name. It's this one here. So this is also a domain name. In fact, we can look this up. Maybe Dig will do it for us. Yeah, okay. It doesn't want to. It's okay. So here, the address that we were looking for was this. You may notice that we're kind of putting it in backwards. So 46.1.217.172.internetaddress.arpa. So whoever is in charge of the 172 part of the internet, right? You may remember these autonomous systems having different prefixes of the internet. Someone is in charge of a large chunk of it, 172 here. So the server for 172 controls who is the server for 217, right? So here, 172. So we're starting by ARPA, and then we look at in-adder, and then we look at 172, ask them about 217, ask them about 1, and ask them about 46. Finally, we've received an answer from a name server in charge of, properly in charge of this subnet, and therefore able to answer the question about that one IP address. So there's only one answer for that. There's always just one name in that direction, I think. But in the forward direction, like from a name, there's a ton of names to IP addresses. There's no really control of who gets to point at a certain IP address. There isn't really a way to even enumerate all the host names on the internet. If you have a name, you can look it up, but you'd have to kind of look up every name you can come up with if you want, and that's really very many. So that doesn't work. Questions? We have a few minutes. This homework will be due in 2 weeks. I will update the description and post the template sometime this weekend, and we'll discuss it more. And yeah.
So we can go from domain name to IP address, and that's always just kind of a one map, right?
Yeah. And then there's another map in the other direction, and they're unrelated.
There's another map in the other direction.
Right. That's this in-adder thing. Right? If you have an IP address and you really want to know, like, what's a good name for this, it doesn't really say who owns it or anything. We can ask who owns an IP address in a different way. That's this who is. I think we did before. Here. Now we'll see who's in charge of it. In fact, it looks like Google is in fact in charge of that address, but that just talks about IP addresses, and the reverse host name lookup isn't all that useful. The forward one is the one that we use most of the time. It can be handy sometimes. You had a question too? No. Okay, let's wrap this up, and I wish you all a good weekend.